Hi everyone, welcome to chapter 6. We're going to be looking at sinusoidal functions this particular chapter. So what we're doing is we're taking your trig functions or your trig ratio of sine, and we are going to be graphing them. Before we can get into any of the actual trigonometry graphs, we're going to have to learn a little bit about something called periodic behavior. And it's basically what happens when your graph repeats itself over and over. So it's just a special type of graph. We do need to know a few definitions so we can start pinpointing different parts of our periodic graphs. The first one that you're going to need to know is the peak, which is the highest point of your graph. So this is an example of a periodic function. We can imagine that this graph would continue in this pattern for a long time. The highest point of it would be a peak. The lowest point of it would be a trough. So the peak, you can think of the peak of a mountain. It's the highest point, and a trough is something that an animal would eat out of. It's like a bowl. So the trough is the lowest point of your periodic function. The cycle of your periodic function is the part that repeats. So if I start here, for example, and because it repeats, you could really start anywhere, but if I start here at the axis and I continue and I follow along, my graph is different up until here. And then it would repeat again after that. So this line that I've drawn in red, that's the cycle of the function. And it's the cycle that repeats. So that's your cycle. And then if I wanted to know how long the cycle is, we have a special name for that. It's called the period of the function. So the period of the cycle is the length of the cycle. Okay, so you've got kind of 4 definitions that'll just identify different parts of your periodic function. Okay, let's identify a few. These are 4 different graphs that we can look at, and we're just identifying which ones are periodic functions and which ones are not. If you take a look at this one right here, you'll notice that there is a repetitive pattern. So it kind of comes up, scoots down, zigs, and comes back up. Okay, so it goes up, down, and up. And then if I were to take this part and copy and paste it, I would get the exact same pattern, right? Up, zigs, down, zigs, up. So we get this repetitive pattern over and over. So this one, yes, check mark, is a periodic function. If I go to question or part B and we take a look at this one, yes, it's going up and down, but it's continuing upwards. The y values are not consistent. So this is actually not a periodic function. It has to be completely identical. So there's no cycle that would repeat and give you the same y values. Okay. If we look down at part C, this is one that goes up and down, and you can see that pattern that I've just drawn. It repeats itself, and it doesn't matter where you start. Okay, you could get that same pattern over and over and over again. So this is an example of a periodic function. Versus part D, when we look at it, yes, it's going up and down, but the heights are different. So this is not a periodic function, okay? So periodic functions have to have a cycle that is repetitive, okay? So it's got to have the same y values and it repeats. My example under this one right here, I mean, I describe that a periodic, I give you the definition of a periodic function. It's basically something that has equal intervals. So just go by the idea that its cycle is repetitive, and you should be okay for identifying them from a graph. You can do this example on your own. I give you a table of values. It's just taken straight out of your textbook. And if you were to create a graph, you should get a periodic function. And this makes sense. We're looking at the visibility of the moon, right? We have full moons, and then sometimes we don't see them at all, right? So you're looking at a proportion of how much of the moon that you can see, and you'll notice that it starts to get larger and then goes back down, and then starts to get larger to 1 and goes back down to 0. Okay, so it's a pattern that repeats. You can graph that on your own. What I really want to do is look at a graph and help you be able to identify the different parts of it, your peak, your trough, your cycle, the period. Okay, so here's an example of someone on a Ferris wheel. And not a perfect circle, but if you imagine a really kind of round Ferris wheel like that, if you are sitting on the Ferris wheel, I know the Ferris wheel goes around and around, but if you're only looking at the height, actually, let's go back here. Okay, at time 0, maybe you're that high. And as you start to travel around this Ferris wheel, your height will get larger until you hit the maximum. And then the height will start to decrease again. And even when you're down here, right, time is continuing, The height gets lower again. My height is still low. My height starts to get bigger. My height is really big, and then my height starts to get smaller again and smaller. So you get this pattern where the height above the ground, right? Here he's at the top of the Ferris wheel, and then he's at the bottom of the Ferris wheel. You get this pattern repeating itself over and over. Okay, so this is an example of someone riding a Ferris wheel, and you would get this type of cycle happening. All right, so let's take a quick look at each one of these. What is the period of the function? Okay, well, the period is the repetitive portion. So we look here. I could start here. If you want, if this maybe isn't clear and you wanted to start at a different point on the graph, that's absolutely fine. I usually start here, but I always double check my math and find a different point and compare it. So here, we'll start right here. And I notice I'm at the lowest point. I'm at the trough of the periodic function. And it goes all the way up, and then every part of every y value is, or every pattern is a little bit different until I get back down to here. And now I notice that this cycle would repeat over and over. So this is him at the bottom of the Ferris wheel. He goes all the way around and back to the bottom. So that's one cycle. The distance of that cycle takes 8 seconds. Okay, so what is the period of the function? Remember, the period is the distance of your cycle. So the period is 8 seconds. It represents the amount of time it takes for Trevor, to travel around the Ferris wheel. Can't type today. There we go, Ferris wheel. Okay, so it takes 8 seconds for him to start at the bottom, go all the way around the Ferris wheel, and land at the bottom again. Part B, what is the highest point Trevor reaches? They're asking for the peak, so the highest point. If he's on this Ferris wheel at 4 seconds, he hits the highest point. Now we're counting up by, I know the numbers are 2, 4, 6, 8, but each square represents 1 unit. So up here, if this is 6, this should be 7. So he reaches his highest point. Whoops. Trevor's highest point is 7 meters above the ground. Okay, now I'm just going to scroll down a bit so we can continue to see the graph and we can answer all of the questions. What is Trevor's lowest point? The lowest point we're looking at is about 1 meter. Okay, so 1 meter. That would represent the lowest point when he gets on and off the Ferris wheel, or just when he's at the bottom of the Ferris wheel. And how high above the Ferris wheel, how high above the ground is the center of the Ferris wheel? Okay, so this is kind of interesting. If this is his lowest point down here, let's do, just because it's clean, this is his lowest point, and this is his highest point. So if you have a wheel, the center of the wheel is here. It's right in between the lowest point and the highest point. So you have to find the middle value, okay? This actually has a special name, and we'll get to it in a couple days. It's called the, we'll come up with the equation of the axis. It's the middle point. So just for today's purposes, if my lowest point is at 1, right, his minimum is 1, and his highest point is at 7, the middle point between 1 and 7 is the average. So just take 1 plus 7 and divide by 2, and you should get 4. Okay, so he is 4 meters, or the center of the Ferris wheel. We'll just make this some smaller writing so you guys can actually see what's going on. Come on. There we go. Sorry, the center of the Ferris wheel is 4 meters above the ground, okay? Now I'm gonna draw in that equation of the axis, or that axis line, just so you can see. So it should be at 4. There we go. And at 4, here it is. And this is a good way to double check. So you can see it's 1, 2, 3 units to the maximum. And if I go down, it's 1, 2, 3 units to get to the minimum. So yeah, we've actually got our right value. Okay, so for today's work, all you're doing is just getting used to identifying periodic functions, finding the peak, the trough, center points, cycles, and periods. Okay, guys, have a great one. Take care.